will immensely help our listeners. So before I begin, I would like to briefly introduce our speaker for today and would like to give you the details of some general instructions, and then I will hand over the session to you and you can start. You can present your screen and you can start. So,
yeah, sure.
Yeah, let me just a minute. Yeah, I think my screen is visible, right?
Yes.
Okay, so again, good evening, everyone, and welcome to this talk on hands-on introduction to containerization with Docker and Kubernetes. This is being conducted by the IEEE Kharagpur section, CSSBC, that is Computer Society Student Branch Chapter. And our speaker for today is Mr. Dipanjan Patra. He is the Associate Software Engineer from Oracle Cerner. So just a brief bio about Mr. Patra. So Mr. Patra is a computer and tech geek who loves all things related to computers and their applications. Personally, he is my friend and I have known him for the last maybe 10 to 12 years, and he is a great person, that I can assure you, and he is great at all things related to computers and technology. He is very interested in these things. He has done his BSc honors in physics from University of Calcutta. He was actually my batchmate, so personally I feel very delighted to have him today as a speaker for this particular talk. After that, he did his masters from the Heritage Institute of Technology under Macau in West Bengal, and he is currently working as an associate software engineer in Oracle Cerner Healthcare Solutions. So one of his favorite activities of Mr. Dipanjan is he used to frequently, during his academic days, he used to frequently provide tutorial talks, demonstrations and presentations on various exciting topics on latest technologies and developments. So today he will be similarly giving us a hands-on demonstration on Docker, containerization and Kubernetes, and I hope that it will be a very interesting and exciting event. Before we begin, let me first give some general instructions to all the candidates who are present here. So please keep yourself muted during the talk and please wait till the end to ask questions. So there will be a separate Q&A session at the end. However, since it will be a hands-on sort of demonstration, some question may come to your mind while something is being displayed. Do not immediately ask your question. I suggest please write that question in the chat box, and from time to time the speaker will take his time to answer the questions that have come in the chat box. So this can also be followed. So an attendance sheet will be distributed. Please note your attendance over there, and you may type any query. So other than the question, if you are facing any query or issues, you can also type it in the chat box and we will try to resolve it ASAP. We will be taking a group screenshot of the event at the end, so if possible we would like to request you to kindly turn off the camera when asked to. So with this, I would like to now conclude the introductory session, and I will stop presenting my screen, and Mr. Patra, it's up to you. So I would like to hand over the session to you. You may start. Thank you very much.
Thank you, Kuntel, for that amazing introduction. So I'm Dipanjan. I'm currently working as associate software engineer in Oracle, as Kuntel mentioned. So I have some introduction to this talk before I get started actually. So I have designed this talk for absolute beginners. So even if you don't know what containers are or Docker is, you should be able to follow along. And so for Kubernetes, I have designed only the basic Kubernetes stuff. So we won't be getting into nitty-gritty of Kubernetes and how to deploy complex Kubernetes clusters. So that is just some introduction to this before to get your minds adjusted what kind of content you are going to get. So okay, I'll screen now. Okay, is it visible?
Yes, we can see it.
Okay. All right. So what is Docker? Let's first get to that. So if you are a programmer or write code for anything, you know that anxiety you face when you have to share your code with someone else, right? So they will try to run it in their computer, and if you work in lab environments or in software companies, you know that your code runs very well on your machine because you have some libraries that are installed in your machine. But whenever your colleague or friend goes to try run your code on their machine, they suddenly get hit with a wrong Python version error, or probably some library that is not available in Windows or only available in Linux. This kind of issues they face, or maybe they have a wrong OpenSSL version, so that could be a deal breaker for the application to be compiled, right? So they tell you that your code is not working, but you know that your code is working, and you reply with, but it works on my machine. So wouldn't it be great if you could just ship your machine to the person and they could run the code in your machine only? So Docker is exactly that thing that will help you ship your configuration to your friend. The whole programming environment you are using is basically shipped to the person you want to share your code with, and that will make sure that every time your code is run, it will run within the same environment. So there might be people among you who are already aware with technologies like virtual machines. So you may have some ideas that you can do the same with virtual machines as well, right? So, but virtual machines are a little bit different from Docker containers. So I will explain the architectural difference between that first. So for a virtual machine, as you can see here, that there is a computer server, that is the hardware. On top of it, there is a hypervisor, that can be KVM, Zen, or anything. And on top of that, your guest OS is running. So after that, you have binaries and libraries, and then on top of that, you have your application. But the whole package for a VM, if you want to share this VM with your friend, what you have to do is you have to package this whole thing together: the guest operating system, binaries and libraries layer, and application. These three things you have to package in a big, large ISO file or image file. You have to share it with someone. It will probably be like 4 or 5 GBs of file, and you have to share it with them, and they have to install it inside their virtual machine, and then it will work. But for container, as you can see, we already get a ready-made runtime engine, that is Docker, which runs on top of the guest OS. So you can think of it like that: only one virtual machine is running, and on top of it, we are creating separate boxes for different execution environments. So say for one of the environments, I select OpenSSL 1.0, that will be one of the libraries, and we will create another environment where we will have OpenSSL 3.0. So there will be complete segregation. So sandboxing is a feature that gets there in the container by default. So this is the architectural difference, and there is another benefit here, that in virtual machines you don't have any standardized way of sharing your virtual machine with someone else, right? So what you have to do, you have to first create a virtual machine using VirtualBox or VMware Workstation on your machine. Then you have to install your OS onto it, Then you have to install your libraries onto that OS. Then you have to run your application on that OS and see that it is working. Then you have to freeze the whole virtual machine in an image. Then you have to share that image with someone else. But all of these things are not standardized. So one person can be using some VMware workstation, one person could be using VirtualBox, and one person could be using Linux OS as their host operating system. One person could be using Windows for their host operating system. To automate this whole process of creating a virtual machine to getting an image of the virtual machine which you can share, this whole process is not basically standardized. So you can write some custom scripts for it, but it will again only work on your machine. So there is no guarantee that it will work on someone else's machine, that script. So for Docker or any containerization platform, that is the primary problem they also solve, that they give you a standardized way to define the specs of a environment your code runs in. So that way your code is every step of the process, like creating the machine, installing which OS to use, which libraries to install, everything is standardized in a particular Docker file, and it will be completely replicable in any system. And also, since Docker containers don't always ship the guest OS itself, they only ship the binaries like library layers and application layers. Their image sizes are largely, mostly smaller than having a complete OS being shipped. Also, usually these guest OS that you install on virtual machines, they are more general purpose OSs, and Docker containers use very lean and minimal OSs which have only the libraries needed for an application to be run. They don't have any other unnecessary operating system components which might be eating resources on the virtual machine, right? Okay. That's why containers come in. So let's talk about the use cases for containers. I primarily use it in two different ways. So first would be running applications that I don't want to install in my host machine normally, right? So say for my MySQL database or Oracle database, I don't have to use those, I don't have to install those, and they keep running in the background and they keep eating my resource. I will only need them when I'm developing some application which needs a database, right? So that way I can only spin up a MySQL container and work on that one, and then when my work is done, I can just delete that container. That way none of my system files are changed. I don't have to clean Windows registry. I don't have to touch anything else, right? That is one way. And there is another benefit for running containers, that is using different versions of the same application. So say you have your project needs to support MySQL 5, MySQL 8 both, and you can actually configure Docker containers. So multiple containers are running on different port, but both are running at the same time, right? So it will be a little bit difficult to install two different versions of MySQL on your host machine and then configure them to run simultaneously. I'm not saying it's impossible, but it will be very dirty. So that is one use case. And another would be to actually use Docker to containerize your application. That way you freeze your application requirements in a Docker file, and it is always replicable in any other machine. That way they can also run your code without any issues. Okay, so we'll get started with some hands-on demo. So running Docker containers. So I hope everyone has Docker containers, Docker installed. If not, I'll just show quickly how to install it. Just give me a second, I'll share my screen again. If you go in docker.com, you can go to products and Docker desktop. You can do this download for Windows, download for Linux, download for macOS, whatever. It will give you a Docker. It will give you a exe file, and you can just install that. There is no complicated steps. So this will look like this, and yeah. So if you guys want to follow along, I'll just paste the link in the chat, and you guys can install it, kids. I'll wait for that. Yeah, I hope my screen is visible now. Okay, first I will show you how to simply run a MySQL database without any frills, without having to install it in your machine. Say I'll name MySQL, and okay, let's do the simplest command first. So I'll do docker run MySQL. Let's say you want to run MySQL version 8. Okay. So it is giving me error that these variables are required. So now I'll go ahead and try to run MySQL 8 with the following command. This D is actually not needed always, but I'll just provide it as it is. Let's say you want to run MySQL 8. It has started. So how do we connect? How do we see if it is running? I have the Docker container here. So you can see this is running at shell. If I do at shell, it is inside the container. if I want to close, just give me a second. I'll download the. I think I have. Just let me open the. Alright, I think I know why it's not working. So what you have to do is you have to expose the ports for it to work. So we'll add the USB command 3306. Yes, it was. Okay, the content is already run. We will just stop here. Share my whole desktop. That way I don't have to see what I'm doing. Yeah, as you can see, this MySQL 8DB is running right now, but it is not exposing any ports. So I'll just stop it using the Docker desktop, and then I'll delete the container. I will create the container again using the fresh command. Is the text okay, or do I increase the text size? So right now I have a program open which can connect to running database. I'll just add a new connection. MySQL. Localhost database password is get test connection requires should come public key to is not allowed. We can go here. Okay, I'm currently running the MySQL database, but it is not some getting attached to the database explorer I was planning to use. Okay, let's attempt to run some other containers. I'll get back to this one because I have an application ready which is using a MySQL container that we will show later. For now, I'll stop this. And okay, let's see about engineers. If I have port 80 and I'll expose it to 80 and I will run the engineers container. Okay. So it is running. If I go to now localhost 80, I should be seeing. That's wrong. There should be no problem getting a container of Nginx container. Okay, it's working. So if you see this Nginx is running inside Docker right now, and here we see that we got a request from Mozilla Firefox and it's showing the GET request, right? So if I cancel it now and refresh the page, we should not be able to connect because the service is down. So yeah, the service is down. I'll start it again and I'll try to reload that. So as you can see, this is how you get a Docker container to run with the port. So this is the port that is used inside the container, and this is the port where you are exposing it. If I expose it to 81, will it work? Check. Okay, so you give the, I was wrong. So you set the host port first, so where you want to access your container first, and this is the port that is being used internally by the service running inside the container. So if I do it like this, 80, so now I can go localhost. Okay, so it's working. All right. Now let's try some other containers. We will Okay. So let's try the Python one. So nothing we have to do here. I'll just directly use the command. So docker run dash dash rm. This dash dash rm flag will do something, that is, it will remove the container after the execution is done. So I'll show it for Python 3. Say Python 3.9, and we want to check, we want to say Python -m http dot server. Okay, it will now pull Python 3.9 image, as you can see. And if you see here, there are multiple layers that are being pulled. So these are the layers of application binaries and libraries. So if one library is already existing in a layer, this layer will be reused for other containers as well. So say if you are using a Ubuntu 16.04 base for your application to run on, then say this layer contains the Ubuntu 16.04 base image. So this layer won't be again pulled from the repository. So next time you build a second application that is based on Ubuntu 16.04, it will just reuse this layer. So this is why the Docker image size is very small compared to a whole virtual machine also. So we'll just wait for it. Okay. I forgot to add the code. Let's add the code. Expose it. So let's say 50, and it was running 8,000, right? 8,000. Now if I go here and yeah, see, it is now showing us the contents of the directory. So I don't think we will be able to see everything, but this is showing us the root directory of the Linux operating system that is being run inside this container, right? And you can see this GET request, how it is going. Okay. This is a built-in Python HTTP server. I just did it to test. Now I will close this, stop this, and let's try now Python 3.12. Okay, same code, but you will see that it will pull lesser number of layers. So as you can see, this layer already says this layer already exists. So it only pulled 3 new layers. If I go refresh it, we should still see the same, because it is the lean OS that is running under root. I think it's a Ubuntu OS. You can explore this, or you can do something which I will show you later. You will be able to copy your files to this. Okay, now we go to the next slide. Just let me go back to the slide. So now we will talk about building your custom containers. So what I showed you, that Docker Hub has different already created containers, and we will now create our own custom containers with our own requirements, right? So like in this image, it shows you how to create a Jupyter notebook inside a container and host it. We will just get started with that one. Okay, so I have already prepared the files for beforehand. So for this one, this is the Docker file syntax. So first thing you do is use a base image. So for this one, let's say I want to use Ubuntu 20.4 for my container. After that, you install your necessary libraries. So if you have used Ubuntu in anywhere, you know that we have this apt-get command, and we use it to install software in Ubuntu. So this run command will run your instructions once. So it will run and then exit. It will change the image, but it will not keep running. You cannot use something that keeps running. You have to use some command that will exit. So after what we are doing here is we are updating the package repository, and then we are installing Python and Jupyter notebook on it, and then we are setting the work directory. Work directory means when you log into the app, log into the container, or wherever the application file will take it as its current directory. So this Jupyter command will be running from inside this /app directory, right? And then we are setting the entry point of the container, that this is basically what command to run that keeps running inside the container. This is a web service. So this is the command Jupyter space. So it's basically removing the space and using it as a list of string. So if I had Jupyter notebook allow and dash equal to it. So if this was the command, this will look like this inside a Docker file, right? So let's build this image. Then this is our custom image. We have created it, and we will now build this image so we can run our custom code inside. Here we are not using any code written by us, but we are just trying to run some software that we don't want to install in our system. Say Jupyter notebook is a complex software, so I prefer it to use it inside a container and not inside my system, because it messes with system files a lot. So we'll get started with this one. So the command to do this is docker build. Then first let me show you the current directory, which files we have. We can safely delete the other files. Don't just delete them. These are not required. So we only need a Docker file, right? We only need a Docker file, and if I ls here, we only have one file. Now we will write docker build the directory where the Docker file exists. Since I am already in the directory, I will use dot, which means the current directory, and we will use a tag for our image. This will help us identify the image later. It needs to be unique from other images. If you use the same tag, it will just override the previous image. So for this one, say we will give ex2 as tag name, and we will say build. As you can see, it is building the image. It is pulling down the necessary layers. And now, as you can see, it is running apt update and apt install. Everything is happening inside the container engine. This apt get update is not running in your host machine, it is running inside the container. Okay, now Python is being installed. Python and Jupyter is getting installed. Update was done. It's installing the libraries that we need to run Jupyter.
I would like to interrupt once. Sorry, as it is being installed, I would like to ask all the attendees over here to please register your attendance in the form whose link I'm pasting in the chat box. If you have not already done so, please register your attendance. Thank you.
I think the build had some issue because there was an interactive prompt there which cannot be handled. So I'll add an environment variable. This environment variable says that the prompts don't ask for user prompts, select anything that is default, because otherwise it's getting stuck. It's waiting for user input, but there is no way to provide user input during Docker build. So right, I'll just run the build again. our image is built now. So we will now run the image we built with docker run dash rm, because we want the image to be deleted when our run is complete, and we'll add interactive shell with id, and then we'll put the image name plus ex2, right? And we have to remember to expose the image over the network, right? It is running on port 8888, so we will have to add a we will have to add a dash b flag here, 8888, and expose 8888 x2. So as you can see, it's showing us the Jupyter notebook has started. Now we have to click this link and yeah. So you see, it's a instance of Jupyter running here. No notebooks are running right now. So what we can do is we can create a new Python notebook, and here you can run all Python commands. Print hello world equal to export now we can print a. So as you can see, Python is working here. So we will check the log here again. It's still running. Now what we will do is we will save it and then close it, and then what we will say is quit. Okay, it says you have shut down Jupyter, and you can close this tab. I'll close this tab, and as you can see, the Docker container has stopped here also. It was shut down. So you may assume that the file we created, it will still be there, but it won't be there, because this image will be booted up again from the state it was created up to here, right? According to Dockerfile, this is the point. This is the point where the image will be restored back to. So anything after this you have changed inside the container, it will not exist. That is the container, and this is the image. That's the difference. So image is ending here. Image is like a template file. You can think that it will create a fresh container from here, and after that you can run anything inside the container. And there are other ways to persist your work using volume mounts and other stuff that I will show right now. But other than that, your container image is always going to start and so if I run it again, and if we go to copy this and go here and paste this, you see that file doesn't exist. So you may be wondering, how can we use Docker container with notebooks to preserve our work and all that? So that's what I will show next. What you can do is, I will close this. So using the same image and same configuration, I'll just mount the current directory inside the container, right? So the command for it is -v. You have to add -v flag, and inside the command, inside the container, you have to mount to this directory. You don't have to mount to this directory, but since our container is using that directory as its base directory, so we give it that. So what it does is, it will mount this ex2 folder inside the Docker container that is running right now. If I run this command, okay. So similar way, I'll have to copy this link. We will go here, paste this link. See, we can see the Docker file because it was mounted inside, right? What we can do is we can create a new Python kernel and we can do the same print hello world, and I'll set comprehension right now. Yes. As you can see, this is done. So if we save it and then close it, we open it again, it's here, we close it, we quit the instance, here the kernel is shut down, but here you can see the files that we had there, they are out here. So close the terminal so you can better see. So here you can see that the state has been preserved, but if you run this command again now, yeah, if we run the previous command again, see the kernel exists here, so that's it. We'll close it and kernel is shut down, and now I will remove this mount point and you will see that it starts fresh container again. See, nothing is here. So that's how you create your custom containers. You can add multiple lines. Some Docker files are very long. You can add as much customization as you want. So next we will go to our next exercise, which is we will have our own app. We will containerize our own application. So what is our application? Our application is a fast API app which just creates a REST API endpoint which responds with hello world, right? It's a simple app. It's an API, backend API. We have this requirements.txt file for Python project. These two libraries are needed, and we have the Docker file. Let's read the Docker file before running it. So we are using a Python base image 3.10 slim. If we go here, I don't know. Yeah, so this Python base image that I opened. So for tags, you can browse here. For a particular version, you can search here 3.11. Yeah. So it will show 3.11, right? All the tags. So tags can be having information for different things. So 3.11 Alpine is a different Linux distribution, and the 3.20 is for Alpine's version. So Windows Server, this tag means that your Python is running inside a Windows Server core, and the Windows Server core version is 1809. So like this, different tags are there. This is 3.11.9. Okay, so in the first overview page, you see the sample attacks, right? So we are using Docker, we are using Python 3.10 Slim. Then our working directory is /app, and then we are copying our requirements.txt file. Okay, only the requirements.txt file is getting copied to the current working directory inside the container. Okay, dot represents the current working directory inside the container. So which will be this /app, and then we will install the required Python dependencies by running pip install no cache dir requirements. This will install the libraries mentioned in requirements.txt, and then we will copy all of our files inside the current working directory. This means everything inside the current directory outside the container, and this means everything inside the current directory inside the container. Copy them, and we are setting the command to run the application. We will use this uvcorn library to run our Python application. So it is going to run in port 8000, right? So let's build this using similar. Sorry, it's not a build command. Yeah. So we'll build this. As you can see, that error. Okay, my bad. We have to go inside the product first. Build that minus d. We call it exercise 3. Okay. See the build completed instantly because every layer that it required was already pulled there, already available offline. So it just ran through the steps very fast. So you can see that cached, it says cached. That means this layer already existed, right? So our application is now built inside a container. So we can run our application like this. Docker run. We want to run on 8000. Right. Dash B. Also add dash dash I and dash dash B. 8000. And our container name is ex3. So as you can see, it says started server process waiting for application startup. Application startup complete. And now we will go to this library I have, where I have to send a GET request to this HTTP endpoint, and it will send me message hello world. It will send multiple times. You can see here it says 100. Okay, message hello world. Okay, now you can see Control C, and let's put some more info here. Message hello world from let's add. No, let's add. Yeah. Then we will run Docker build again. It will update our application. We will run the application again. We will go to this update. So as you can see, it got updated instantly. Right. So we can also add a random number. You have to close it, you have to clear the container. Now we run the container again. Mention the request. As you can see, on every request it is sending a random flow. Okay, so you know that every request is unique. That's how you containerize your own application. I just used a simple application, so for ease of understanding, you can have as complex application as you can imagine. You just have to clearly define your running process of application. That can be a bash script, that can be a Python script, it can be Node.js application, it can be React application. It doesn't matter. What you have to do is you have to think that this is the base image. On top of this image, I will make these changes. After these changes, I will finally run this command to start the application. That is your. This is the standardization I was talking about. So it is giving you a very clean way to define your work steps to get to the application running, right? So this is done now, and we will now go back to the slides. So far, do we have any questions? So this is the demo I already showed. So containerizing an existing application. I provided the code here in the slide. Okay. Then we are going to move to the next one. It is called Docker Compose. Docker Compose is a way for you to have multiple containers running. So this is the example I said that I'll show. Where MySQL is running in a container and our application will also be running in a container. This container will access the MySQL container to get a database and write to it. Alright, so we'll get started with that one right away. Okay. Okay, I'll shortly explain the files we have here. This is our application. It is again one of the fast API applications. So we will have some routes here. So you can see there is a root for hello world, and then we have another root which is for slash items. So whenever we send a post request to slash items root, we are going to be saving data inside the database, and whenever we are going to call the get items, we will get list of all items inside the database, right? It's a simple application, and this is the database configuration. It is picking up from environment variables. All right, and for requirements, we have fast API, Ubicorn, like I mentioned, and MySQL connector Python. This is necessary for connecting to MySQL database. For the database, we have a initialization script. This create table if not exists. This will initialize the MySQL database by creating this table. We have only two fields, name and description of item, and this auto increment primary key, it is automatically going to get filled. MySQL data, this folder has nothing in it for now. There is a reason this folder is here. I will show later. And now we come to Docker file. So the Docker file says that we will use Python 3.10 slim image. We will set work directory to slash application inside the container slash app. We will copy our app requirement file, app requirements.txt file, because as you can see, this is inside the app folder. So we have to give that. So this path is always going to be relative to the Docker file. So Docker file is in the ex4 folder, and the path is going to be app slash requirement.txt, and then we are moving it to work directory. We can also write dot or this is basically same. Then we install the requirements, then we copy the current directory, this app directory inside app, and then we run the program using the same ubicorn command on 8000 port 8000, right? Okay. Now what we have here is a Docker compose file. So this will let us define two different, not two, I mean it will let you do as many containers as you want running different services. So first service, you can see DB, I have named it DB. It is using the image MySQL 8.0. This is basically the Docker hub image name that we were using earlier. Then we are setting the environment variables. Root password we have set example. Database name we have set testDB. We are exposing the ports 3306 to 3306. This is the container port, this is the host port. Then we are attaching some volumes. You remember that using -v we added volumes. So what we are doing is current directory MySQL data is connected to varlib MySQL. So any changes inside the container will get reflected outside, because this folder is getting mounted as an internal folder of the container, right? And same thing is happening for the init SQL file. So this file, this file is getting run every time the Docker entry point initdb.d. So whatever SQL file is inside this folder, MySQL, when starting up, will execute that SQL, right? Okay, then we have a second container which we have named web, and it is going to build the current folder. So Docker compose is in ex4. If I close this, Docker compose.yaml file is in the ex4 folder, and Docker file is also in the ex4 folder. So we are using dot to say that wherever the Docker compose file is, start a Docker build in that directory. So it is going to find this Docker file and run Docker build on this file, and then we will expose port 8000, and then it will depend on a service whose name is db. So if you remember, this service is named db, it will depend on db. So what it does is it will first start this container, and once this container is ready and up, only then this container will attempt to be get started. Then after that you have environment variables, which we are setting. Database host is db. It is just going to use the service name for host name. Then database user is going to be root. Database password is example as we are setting here, and database name is going to be testdb as we set here, right? So we don't have to use the Docker build and Docker run multiple times anymore. So you just create a YAML file like this, and you go into the directory, and if you see that I am already inside the directory, and you run docker compose up -d. This will start in detached mode. See, these are now running container x4 db1, x4 web1. Two containers should be running. If you see here in the ex4 container enclosure, you have two containers, web1 and db1, right? It is running MySQL 8 as you can see. Now I'll go to the library I mentioned. First, I'll try to get the items. It is returning an empty list. Alright. Next, we will try to add some items. First, I'll add in the body, we'll add a post. Since this is a post request, we have to provide name and description. Name used to play cricket. We'll send this. It was added. It was added, and name. Then we'll add football. Used to play football. Okay, we'll go to the get items again. We'll send the request, and as you can see, these files have persisted. If I use get request again, I don't get any more items. But what will happen if I add another item? It will show up there. Say biryani is to, and you get this. So now I'll show you how to close the containers. You can see they are running here. I pin this. Just a second. Okay, now the window is pinned. What you have to do is remain in the same folder where Docker Compose is. If I ls, you can see the Docker Compose file is here. So what I will do is Docker Compose down. It will tear down the containers. As you can see, they got torn down and they got removed. So this way, what you can do is you can have a set of containers which depend upon each other, and you create a Docker Compose file for them like this, and you keep it in a directory, and whenever you need that stack, you just update that. You just go into that directory and run Docker Compose. Okay, Docker Compose is done. We'll go back to the slides for now. as you can see. It's also here given the code. Okay. Now we'll move to the Kubernetes part, but before that, I would like to answer any Docker related question if anyone has any.
Yeah, so I request the audience who are present to ask any questions if you have to the speaker. Otherwise, we will go to the Kubernetes, which is, I think, the last part of the talk.
Yes.
So I don't think there are any questions, so you can just continue.
Okay, sure. Thank you. Just give me a second. Alright, so Kubernetes is basically a container orchestration tool. So by orchestration, I mean, like, in oversimplified terms, it helps you to deploy, monitor and manage containers, and it helps you to scale them up. Like if you have, say, 3 containers, say if you have one container running your web service and it can handle only 100 requests per minute, and your user base has increased to 200 and you have to scale up your application. So what you do, you could have easily run 2 containers, but you have to do that manually. You have to start one container and create another container, then run it. So 2 containers are running. Now you have to use some kind of load balancer with it as well, so that requests from outside only hit the load balancer, and the load balancer internally distributes the load between your 2 different containers running. So this is all a management issue because you have to manually maintain so many containers. So that's where Kubernetes was discovered. So it allows you to scale up your web service by spawning more replica containers. Overall, you could say that it takes away most of your manual work on monitoring and deploying multiple containers by using configuration files. Alright. Let's understand some of the terminology and architecture of Kubernetes. Kubernetes works with cluster architecture. So a cluster is multiple computers connected via network. That is the simplest analogy. So even in supercomputers, they work like that only. They are connected by high bandwidth interconnects or networking. So distributed computing is anyone starting distributed computing might find this easy to understand. So Kubernetes will always have at least one node. Node is basically, it can be a virtual machine, it can be your machine, server machine, or your PC, anything. So, and it is almost always that there are more than one node in a Kubernetes cluster. For today's demo, we will work with only one single node Kubernetes cluster, that is my machine. But for any other production use case or any examples you can see in the outside world of using Kubernetes, it will be using more than one nodes. So modern Kubernetes architecture in the cloud does not even let you handle the master node. They call it managed Kubernetes service. But let's not get into those details right now. So I am trying to keep Kubernetes so simple that anyone who understands Docker should be able to understand Kubernetes, but that is not usually the case. So anybody who even understands a little bit of Docker is still intimidated by Kubernetes sometimes. So I'm trying to solve that with this talk. So next thing, terminology wise, you have to understand is a pod. So for Docker, like the container is the smallest unit of computation. So to compute anything, you have to have a container, right? So you can run multiple Python files inside one container, but your main application is represented by one container in a containerization world. So for Kubernetes world, your smallest unit of computation is a pod. So a pod is basically the smallest deployable units of computing that you can create and use in Kubernetes. A pod is a group of one or more containers. So usually there will be only one pod per container, but if you want tightly integrated services where you cannot horizontally scale, there you could have multiple containers in a single pod, and that is okay with shared storage and network resources. So all the containers inside a pod will share networking and storage. This is an important thing to remember. So, and a specification to run the containers. So how to run those containers, that is also part of the pod. Okay. Usually pod will contain one container, like I mentioned. For tightly integrated service, let's say for the example I showed earlier, there is one database, one Python application, and your Python application is directly accessing the database. So that way there will be some network latency, and database could be having millions of rows, and then database will get slow to respond to your request complex queries. So for that we usually use a cache in Redis, in-memory caching, something like an in-memory cache in Redis, or there are different in-memory cache solutions available. So what you can do is you can have two containers inside a pod, where one is running the Python application and another is running a Redis instance to cache the latest queries from the database pod. So the database pod will respond with queries. This will be cached in the Redis instance. That way Python will not have to always query the database. It can pick up the frequent queries from the cache. So this is one way you can imagine having multiple containers inside a pod. Okay. Next, we'll get started with the hands-on demo for Kubernetes. First, you need to have some library that will let you run Kubernetes on your machine. I'll show it right now. So what we are using is this Minikube library. This will, as you can see, Minikube quickly sets up a local Kubernetes cluster on any macOS, Linux, Windows. Okay, so if you have noticed, my Minikube is already running, and I'll show the commands for Minikube here. I've stopped the Minikube cluster, as you can see, and I will Now start it again. To install Minikube, we can go to this link and get started. Here you have some information. If you are running Linux, you can click on this. You can select your architecture. You can download using this Debian package, RPM package, or Windows. I think it's better to use Windows Package Manager or Chocolatey Package Manager to download it. Or you can also download using exe file as well, but there are some additional configuration for that. But anyways, you can download from here. I'll send the link here in the chat. Okay, I have started Minikube again. Now there is one important command for the most important command for Kubernetes is kube control or kubectl. kubectl. You can check the current nodes that are running. As you can see, it's showing Minikube ready, and it is a control plane. So control plane is the master node that I was talking about. This has essential Kubernetes related services that are running inside. Usually it is not recommended to deploy any code inside this Kubernetes cluster, but we will be for demo using this cluster only. Okay, now you can check if you have any pods. See, there are no pods for now. You can also check if you have any deployments. No deployments are there. You can check if you have services, any services running. And if you will see that we have a Kubernetes service running. This is a system service for Kubernetes. This will always run. This is the service you might be interacting with. So I don't think this is the service you are interacting with, but this is internally managing the Kubernetes related services. So yeah, let's create our first pod. I'll just pod. I'll give it a name, Nginx. Then I'll define which image to use. That will be Nginx. So is it this? Check syntax. I think you use run command. Run in Nginx pod. Yeah, kubectl run Nginx. Now if I go and check which pods are there, you can see Nginx status is container creating. It will update once the container is downloaded and running. See, it's now saying that container is running. Alright. Now I will delete this because this cannot be accessed internally. Okay, let me show you that it is running inside Docker PS. See, this is the container that is running Docker interpret. If I Docker exec and this sorry. Yeah, so I got a terminal access inside Nginx. Just give me a second. Okay, I'm inside this. This curl. Now if I do curl localhost, backspace is not working. See what I curl. See curl. Okay, so as you can see, this is the HTML that is shown when in the next. I will exit here. Try list the containers running inside again. You can see that there are multiple corners and these are related to Kubernetes services, internal Kubernetes services. Our ones this one. What we will do is Docker. Yes. This container names Nginx. Notice container. This is the pod running. We will just move to the next part because this pod is currently not exposed to the outside. You cannot if I say miniq IP. This IP is your node's IP. So if I see URL to this IP, there will be nothing because that Kubernetes by default does not expose the pods networks outside. So for now, what we have to do is kubectl delete pod Nginx pod Nginx deleted. Now we will create the pod using a deployment. What is a deployment? Deployment is a definition similar to that, but a deployment will help us launch multiple replica containers for something. Let's do the same for Nginx kubectl create deployment tested. Let's name the deployment Nginx deploy. So let's name this Nginx. We will have test as image equal to Nginx. And we'll say enter. Okay. So we now say kubectl get pods. You will see there is a automatically created Nginx pod, and there is a deployment as well. See, it says Nginx 1/1. Now what we can do is we will delete it for now. Delete deployment Nginx. Now if I check pods, there are no pods. There are no deployments as well. Now I will run the same deployment but with replicas. 1, 2, 3. Okay. Now if I go to the pods, you can see 3 pods are created. Earlier, if your application had to scale up, you had to manually restart, manually create a pod or a container. But here you can see that your containers are automatically created. 3 containers are running inside 3 pods. So in deployment, as you can see, there is 3 by 3. Now you may think that what happens if a container pod is getting deleted. So let's delete one of the pods. Let's see what happens. Notice the age. Every pod has age of 37 seconds here. Let's check again. 51 seconds. Now we will delete one of the pods. Kubectl delete pod for m pod deleted. Again we will say deployment. As you can see, another container automatically got created. Earlier we had this, we deleted this rbch9, this one. Now we have a new one. The ID is different, unique ID. So if I again, so as you can see, the age of these ones were 92 seconds, but this is just got created, so it is 28 seconds. So this is the one of the interesting things about Kubernetes clusters. You can have self-healing services. So if by any accident one of the container goes down, it will automatically create a new replica container from the image. Alright, now we will create a service to expose this outside. Alright, we'll create a load balancer. We will name it Nginx load balancer, and we will give it load forwarding rules to map 80 to 80. Okay, I think I forgot the service keyword. Okay. We will create a service which is of type load balancer. The name of the service is Nginx, and we want to expose port 80 to port 80. Service Nginx was created, and now you can see get pods, get deployment, 3 containers are running, and get service. See our Nginx load balancer service is up. Now let's connect to the service. Ideally what you will do is your node IP and this port number should give you the should get you to the service, but in my case it won't happen. I'll just show you right now. Minikube IP. I have to take this port. See, it will be unreachable, right? But what you can do is, if you are using Minikube, you can say Minikube service and the service name. Service name is Nginx, right? We'll write this and enter. It will create a tunnel, and in the tunnel we have Containerize. If I refresh this, it is sending request to all of the 3 containers, right? It is running load balancing service over on top of all those 3 containers. Now I'll just close this. Now we will delete all the resources that we just created using this delete command. As you can see, everything was deleted. Now if we get service, we will get nothing. Get deployment, we will get nothing, and we will get no bots as well. So the same thing I did here now can be done using these deployment command and these YAML files, right? So these YAML files are created very easily by using this Docker, this Kubernetes extension for VS Code. So you can have, say, new file test.yaml, and you can say service, or you can say deployment, Kubernetes deployment. If you can expand, you can add like Nginx, right? Then you have to add the image name. Then you have to add the container code, say, okay, like this. So that's how I generated this deployment configuration for Nginx. Here it also has resource limitations, so how much memory it can use, how much CPU it can use, 0.5. This is currently set to use 0.5 of a single CPU, and here you can mention how many replicas of it you want. So this will always have, this instruction will tell Kubernetes to always make 3 containers of this deployment available at any cost. So let's quickly deploy this file. Kubernetes deploy. First change the folder. Have to go inside this folder. Apply. I'm going to apply this deployment file. Name of the file is Nginx. Deploy.yaml. Deployment was created. You can see get node, get pods. See, the deployment was created. There is still no service created for it because there was no definition for creating a service in this YAML file. So for service, what we are going to see uses another YAML file, kubectl apply Nginx service. Yeah. Now service is also created. If I give service, you can see the service is created, Nginx load balancer. Now we can access the service again using Minikube service Nginx. you can see, this is available. And now we are at the point where I will show you the proof that Nginx is load balancing. I have this secret deployment thing. It will create a Python application like we mentioned earlier, this hello world application, but it will also send you the platform's host name, the machine's host name. It will also send as part of the request response, and it is a very simple file, so it's there. I've already built it and uploaded it to my Docker hub, and this is the image name. This is already uploaded on my Docker hub. And now what we will do is, okay, let me first show you something else. We will first delete all resources that we created using different files. kubectl delete all. It is not recommended to use this all file, but I'll just show you again. So this nginx.yaml file, it has both the deployment and service definition in a single file, right? You just have to separate them using a dash 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 triple dash syntax. The rest is same, that were individually in the files, the same. It is the same. So we will run kubectl apply dash f and nginx.yaml service created. Wait a second. Okay, it should work without the replicas. I'll just show quickly. Yeah, it was applied, and now if you want to delete it, you don't have to use delete all. You can also use the file itself to delete the deployments. And now I'll just quickly deploy this secret service. ctl apply my deployment. Oh, sorry, I forgot the dash flag. Okay, now the service is there. kubectl get service, you can see. Minikube service. Let's see. Expose the service. So you can see the message hello world, and from this is the host name of the pod that is running on. If I refresh this should change. Here it is D for PTQ. If I refresh again, there was, you can see F9ZDL. I refresh again, it is going to keep changing according to your configuration for load balancer. All right. Okay, that's it from my side. I'll just get back to the slides. Okay, I have added all the YAML stuff here, and that's it. Thank you from my side. Container, you can take over.
Yeah, so thank you so much, Dipanjan. That was a very wonderful hands-on session that you gave, and I believe you covered a lot of things in depth, starting from basic Docker installations to, like, how to have the containers up and running, how to write the application, and then you went on to Kubernetes. So of course, like, it is, you showed with simple examples, but that is enough for the, the participants over here. So as and when, like, the so depending on the exact use case and the application which developer is possibly developing, he or she can accordingly, write the code. But this introductory tutorial will give everyone a platform. So, and this is actually what is, needed the most from my practical experience, also what I feel. So once we are, like, comfortable with the introduction and the, like, basic things, the development follows. Actually, it is not that much difficult. Anyway,
Yeah, definitely.
yeah.
Docker and Kubernetes are just development tools, so there is no need to get scared of them. So they will help you eventually once you have learned actually programming. It's just enhancing your development experience, nothing else.
Yeah, no, just give me. Yeah, sorry for the interruption. So anyway, so before we end the session, the talk finally, I would like to ask the audience present here, is there anyone who wish to ask any, maybe a very quick question? Like, we don't have much time right now, but just one question or one or two short quick questions maybe we can allow. So if anyone wishes to ask, they can unmute themselves and ask. Otherwise, we'll just go to the next phase. Yeah, so I don't think there is anyone that will ask. Anyway, so that's not an issue. I would like to thank Dipanjan once again for your wonderful talk. Let me share my screen once more, and I've